Section 1, Chapter 2, Lesson 2, adding subtracting radicals now. The biggest thing I could tell you for adding subtracting radicals just to think about is when you add subtract radicals, think about like terms. I mean that is, you can add a 5x plus a 3x is 8x, but 5x plus 3y you can't because they're different values, right? Well, when you're doing radicals, it's the same exact thing. A root 2 and a root 2, that's the same thing. So 1 root 2 plus 5 root 2 is 6 root 2 because root 2 is the same value. Okay? But you come over here, a root 5 and a cube root 5, those aren't the same value. So we can't do that. Okay? That's essentially all you have to do. The rest of it's pretty easy. It's just going like terms. Okay? So let's look here. So we have root 2 plus 5 root 2, that's 1 plus 5 is 6. They said to go ahead and check on your calculator. You can if you'd like, but I'm just kind of giving the rule a little bit ahead of time. 4 cube root 5 minus 7 cube root 5, so 4 minus 7 is negative 3. So you can do that because it's the same index and same radicand. Okay, so again, the rule is you can add and subtract with the same index, same radicand. And then this one, 5 root 8 minus 2 root 8 plus 7 root 8. 5 minus 2 is 3 root 8, plus 7 is 10 root 8, so that one does work. And these are the two that don't work. 7 root 5 plus 7 cube root 5, well, cube and square are different, so you can't do that. Cube root 3 plus cube root 2, they're different radicands, so it's on the same value, so you can't do that. Okay, so the rule, we already said it a couple times, same index and same radicand you can combine. Like terms. Okay, think about like terms, okay? All right, so any questions on that? Am I going too fast in explanation, or is it as straightforward as can be? Is that all right? Okay, so then simplify the following expression, answer as a mixed radical. So they do want us to simplify this. Okay, let's look at C here. So you got 8 root 7 minus 3 root 7 plus 15 root 7. So all of them are root 7s. They're all index of 2. So we feel good. 8 minus 3 is 5 plus 15, 20 root 7 is that answer for your mixed radical there. Bless you. Okay. 5th root 10, 5th root 10, 5th root 10, all index the same, all radicands the same. 18 plus 12 is 30. Minus 7 is 23. 5th root 10. And the last one, who cares if it's variables? It's still the same radicand, so don't be confused because it's a root x. It's still root x and root x, so 5 root x minus 4 root x is just root x. 1. You can put a 1 here if you want, but 1 root x. Okay, I'm going to throw a little bit of a curveball here for investigation, but just to show you how simplifying can help you. So, oops. Okay, so root 2 plus root 8 is 3 root 2. 5 root 12 plus 6 root 48 is 34 root 3. So they're saying you can add those and get those values. Does this appear to contradict your rule in investigation 1? Well, yes, radicands are different. So it appears to be contradicting our rule. They're saying we can add those. However, we know from our first lesson that root 8 can be broken down. If you break root 8 down, you get 4 times 2. And then look, you get 2 root 2. Now we're in a spot where we can combine them. So simply put, when you're doing your add, subtracting radicals, they need to be in their simplest form. Okay? Or you want to make sure they are before you say you can't add them. Okay, 1 root 2 plus 2 root 2, that's where the 3 root 2 comes from. Okay, the problem up there, we have to simplify 2 places. The root 12 can be simplified to 4 times 3. The 48 could be 16 times 3. The 4 comes out as a 2. What's that? So 5 times 2, so 10 root, oh, it's going to be, yeah. Okay, let's see. 4 comes out there, so it's going to be 24 root 3. So we got 34 root 3. That's what we're looking at. Okay, which they told us above, right? Okay, this is where we're just going to do a couple practices now, and that's it. Just 3 examples, and we'll be done. That's pretty much the focus today. It's adding, subtracting only. Okay, so write each expression in terms of a single radical. Okay, so these are all, you can see now they just completely went the harder route on you. You have to simplify everything. So you're simplifying, then adding. So like this right here is 16 times 5. So what I always like to do is just kind of, I don't want to say it's a shortcut, but just using your knowledge. If I'm leaving a 5 in, let's check and see what that's going to be with a 5. 20 divided by 5 is 4. So you can see they're both going to have 5s left in. Kind of gives you an idea that you're going to combine them, right? So 16 comes out is 4 root 5. 4 comes out, that's 2 root 5. 4 root 5 minus 2 root 5 for 2 root 5. Okay. And then we're working with cube roots next. 80 and 27 or 270. The obvious things to me is 8 and 27. 8 times 10, 27 times 10. 8 and 27 are both perfect cubes. Pulled 8 out, that's 2 cube root 10 plus 3 cube root 10. Okay, so 2 cube root 10 plus 3 cube root 10, 5 cube root 10. Okay, and C, 9 times 3, 25 times 3, and this would be 49 times 3. See how the 3s are kind of something to look forward to? So this comes out as a 3. Remember, you multiply those. 21 root 3 here. Comes out as a 5. Minus 15 root 3 here. Comes out as a 7. 14 root 3 here. So I got 21 minus 15 for 6, plus 14 for 20. Okay. And here's 2 little bit challenging ones, and we do a little perimeter question here. So throw some fractions at us for the next couple. Any questions at all? Is it okay? All right. Okay, so let's break these 2 down here. So 108, 36 comes to mind. 36 times 3. And this one, you can see 36 times 3, well, this one breaks down to 4 times 2. That's all it breaks down to. So these 2 won't be able to be combined. And that happens. You can't always make them one radical. Okay, you can have 2 types. This one, 16 times 3. This one, 25 times 2. So we're going to have, at the end, we're going to have a radical 2 and a radical 3 type of terms, you could say. Okay, so that comes out. 6 times negative 5, negative 30, root 3. The 4 comes out as a 2. So that's going to be 2 times 3 fourths is 6 fourths. So 3 over 2 you could write it if you'd like. And that's root 2. Minus 16 comes out as a 4, which just cancels that fractional 4. So it's just minus 5 root 3. And then 25 comes out as a 5, so we have a plus 5 halves root 2. Okay, so you look at your stuff here. You got negative 30 and negative 5 for negative 35 root 3. 3 halves and 5 halves is 8 halves, which is 4 root 2. This is your simplest answer. Now I know that I'm going through finding these numbers quickly, and that's obviously because I've been doing, teaching math for 13 years. So if it takes you a little longer, that's not a problem. Okay, definitely just try it. So it might be a little slower, and you'll get faster as you practice.
If you add those 2 things in your calculator, you get the same value.
These 2?
Yeah. No, those and then the top 4.
Right, correct. To check your work, you could put all these in your calculator for the first part. We'll equal this. We're just simplifying. So yes. Okay. All right. This one. So we got a cube root of 64. Well, that's nice because cube root of 64 is actually a whole number. That's just 4. Cube root of 375. So that's going to be broken down to 125 times 3. Okay. And then I'm going to subtract. 54 has 27 goes into it. Minus 5, cube root 8 times 3, all over 2. So this comes out, 125 cube root is 5, so 5 times 2 is 10. I'm going to write the 4 over 8 as 1/2, if that's okay. So this comes out as a 5, so we get plus 10 cube root 3. So this 27 comes out as a 3, which makes negative 6 divided by 3 for negative 2, cube root 2. This right here comes out as a 2, which negative 5 times 2 is negative 10 over 2, which is negative 5. And so you're here. There's only two things we can combine here, the 10 cube root 3 and the minus 5 cube root 3. Which gives you 5 cube root 3, 10 minus 5. And they're there. Organization's key in this, okay? Writing all your steps out, showing your breakdowns, all that stuff's helpful. Okay? All right, last question here. Okay, so now find the length of x. So find the length of x as exact value as a decimal. So length of x is essentially, if we know the whole side is this and this side is this, we're going to go this piece minus this piece, right? So it's setting you up with a radical subtraction. Okay, so you're going to go 8 root 2. Let's go ahead and simplify 2 root 12 now, so we don't have to worry about it. 2 root 12 is 4 times 3, so it's going to be plus 4 root 3. Are you okay with that? I simplified that now. We'll do the same thing for the second piece here. We're minusing 27, 9 times 3. That's 15 root 3. This is 9 times 2. 12 root 2. So you're minusing 15 root 3 minus 12 root 2. It's important to have the brackets there because why? Because it reminds you that this minus here is hitting everything. So this is actually a plus. That's why. Okay, otherwise you'll forget to do that minus a minus. So you're going to go 8 root 2 minus a minus. That means plus 12 root 2. That's 20 root 2. 4 root 3 minus 15 root 3 minus 11 root 3. That's your exact value. Exact means no decimals. Okay. And then simply to get the decimal, you just punch on your calculator. If you put that in your calculator, you will get 9.2. So 9.2 would be the length of this side. Okay. All right, so we'll stop there.